quantum number. So today we're going to go ahead and talk about the magnetic quantum number, and that's the third quantum number. We're not going to give you the fourth quantum number because we don't need to know that until Monday. Monday we'll go over that. And it'll make a lot more sense for me to give that to you then than it would be to give it to you beforehand. Okay? So the next one is called the magnetic quantum number. And that's indicated with the letter M. By the way, did anybody read through some of those pages that I asked you that might be a good idea to read? Did you read through it, Jaden?
Yes.
Did it help?
Kind of.
Okay. It kind of just confirmed some of the things we went through. And then some of the things in the reading might be what we're going to go through today, too. So that will help you, too. It's like, okay, I remember reading that. So the pages that would be beneficial to read through would be like pages 136 through 141. And those are the ones that would kind of go over these characteristics. So we got the principal quantum number. The principal quantum number, just as a review, indicates the location of the electron. Okay, so 1, 2, 3, 4 levels. Usually I just show that because that kind of allows us to get to where we want to. Then we've got this other thing, it's called the sublevel. And it's indicated with letters, and that would be S is in the first, and SP is in the second, and like Rudy said, SPD is in the third, and SPDF is in the fourth. So if you notice, we add on a sublevel each level we go to. Okay? We also realize that there's 2 electrons in the first level, and 8 electrons in the second level, 18 in the third level, and 32 in the fourth level. And then we just keep on adding on. So that's basically what we went through yesterday, and what we're going to go through today is called the magnetic quantum number. It indicates the number of pathways the orbital takes within a sublevel. I need to shorten that down though a little bit, okay? Okay? So it indicates how many different pathways we can have with that same shape. So, we have S. S is a sublevel. And it indicates the different pathways. So how many different pathways does the S have? It has one and only one pathway. What I mean by pathway is that when we have an S orbital, and we're just going to go ahead and show a sphere, okay, it only has one type of pathway it can rotate around the nucleus. And you're like, well, don't they all have just one pathway? Because they should just have one. Well, I'm going to show you P here in a second. And P has 3 different pathways it can take. So when you guys exit the school, are there multiple ways you can get out of school? There's 2 pathways you can get out of school. Okay? To your house. So there's 2 ways you can get here, and there's 2 ways you can get home. And you could probably make up more ways if you want to break the law and go across the grass and go whatever direction you want to go to. But there's really only 2 pathways. So when we say a pathway, it's a direction around the nucleus. Okay? In what 3-dimensional direction does it take around the nucleus? So this is for students that are using this because they're missing, because I'm going to show symbols with balloons here in a second. And so we'll go ahead and show the balloons first. And you're drawing them out. Then you'd show one like this. Okay, and then you'd show one like this. And then you'd show a diagonal one. So this would be along the y-axis, this along the x-axis, and this along the z-axis. And then when you put them all together, that's where you kind of get that look here, here, and here. Okay, which isn't a very good drawing. That's okay. All right? And then, guys, they just keep on adding more and more pathways that you can have. And each pathway can hold 2 electrons. So each orbital is represented by a different pathway. And each orbital can hold 2 electrons. So that's when I did those drawings earlier with, with pairing them up. That's why I'm pairing them up. So the S has 1 pathway. P has 3 pathways. How many do you think the D has?
9.
Nope.
4.
Nope.
5.
5. Okay, and then I bet you guys can guess the last one.
6.
Nope.
7.
7. 1, 3, 5, 7. Odd numbers. If we had a G, so in theory we don't have enough electrons to do a G, but if we had a G, how many pathways would it have? 9 in theory. Okay? So, and each orbital can hold 2 electrons. I think, maybe I gave that to you yesterday, but I'm going to go ahead and tell you again today. Each orbital, where the electrons hang out, can hold 2 electrons. Okay? Each one can hold 2 electrons. So I'm going to have you get your periodic table out, and then we're going to talk a little bit about how we can kind of connect the periodic table with these pathways to make some, because the periodic table really will help you. It's kind of like a map. It's like a Google map. This Google map can let you find your way when you take a look at electrons to a particular element. So we've got 92 that we could find the direction to using our periodic table, but you have to be able to use the periodic table to do that. So I've drawn this multiple times, and we've talked about different areas, the metals, the non-metals, alkali metals. We kind of know the families and those type of things. So when you look at the periodic table, these sections kind of represent the sublevels that are the final sublevels of being filled in that, whatever that area is. So we have this section here. We'll have this section here we'll talk about. That middle section, and then the bottom 2 rows. Okay? So when you look at each section, that represents a sublevel. So what do you guys think that this first section here represents? What do you think sublevel is represented by this here?
S.
S. Does that make sense? It's up there to the S block. Because there's 2. Okay? So why does it make sense that it's 2? Because if you look at this pathway, you only have 1 type of orbital. How many electrons can we hold here? 2 electrons, right? that has one orbital, one pathway, it can hold 2 electrons. Makes sense? Okay? So, the next one we go to is this area here. What do you think that represents? So when we count across, how many do we count across? 1, 2, 3, 4, 5, 6. So that would be the P's. So we're trying to draw connections where these sublevels kind of start working. Okay, we look at the 3 P's, there's 3 pathways. Each of them can hold how many? 2 electrons, right? So that's a total of how many electrons for the P's? 6. We're just doubling that number, right? 1 orbital for the S, it can hold 2. The P's, they each can hold 2. And there's three different orbitals for the P's. That's 6 electrons. Okay? The next one. So what do you think this section is? You count across those, how many do you have when you count across that section? 10. That's the D's. That's the D's. You count across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? This is 1, 2 across that section. This is 1, 2, 3, 4, 5, 6. Alright, so now you know what this bottom section is, right? These are the what? There's 14 across there. That's the S.
What's helium?
What's that?
Helium.
Yeah, now helium's kind of goofy because helium is part of the S. So the reason is like, well, why isn't helium over here? Why don't we put helium over there? Why do you think helium does not go here when we talk about its character? Not maybe a small number. What's that? So, what do we know about this group here? These are the noble gases, right? What do we know about the noble gases? You guys should be able to tell me. Non-reactive. Okay? So, helium belongs over here because it's non-reactive. It does not belong here because these are metals and they're very, very reactive. So that's why helium is over there when we do it, when we look at it. Okay? Alright. So this would be 1 through 14. I'm not going to go ahead and count those all up, but there's 14 there. So now we know the S's, when they fill, they're kind of filling this area. We know the D's, when we get into this area, we know it's going to end in a D. So if we get any of these elements that we're talking about electrons, and we're putting in the final electrons in any of these, we know they end in D's. If we have any of these elements, we know they're going to end in P's, and so on and so forth. Okay? We're going to do a little bit of, give you a little bit of pre-knowledge for what we're going to do on Monday, so that at least you kind of got a clue what's going on Monday, and it'll make it a little bit easier for you. Any questions you guys have? So then if we go back and fill these back in, there's how many electrons in the D's? 10, and in the F's there's 14. Okay? That's just for the sublevels. So these are sublevels, and that's how many they can hold. If you're asked a question, how many electrons can fill the D sublevel, you'll say 10. If they ask you how many can fill the P sublevel, you'll say 6. If you forget, you can count across. 2 for the S's, 10 for the D's. Count across that middle section, there's 6. You count across this bottom section here, there's 14. So if you forget, you kind of know. All right. So what we're going to do is we're going to show where every electron is for aluminum. Okay? So the first thing we're going to do, you guys don't have to write this out. I guess I'm going to have to do it that way. Okay, so let's find where all the electrons are for aluminum. So aluminum's number 13. Okay, here we go. Where's the first electron come in? What level? Okay. Second electron, where does it go? Third electron. Okay, why 2? Why not? Why can't we put another one in the first level? It's going to only hold 2 electrons. It's full. So there's the next one. So we're up to 3. How many electrons can fill the second level? So that will give me 10. We got 3 more. Where do those 3 go? Third. I'll explain why they're paired up here in a second. There is aluminum. Okay? So then somebody asks you, I want more specific about these electrons because I know they're all a little bit different. You go, okay, how can I do that? Okay, I'll tell you a little bit about their sublevels. And so I'm going to describe these first 2 electrons. What level they're in? They're in the first energy level. Those 2. These 2 here I'm talking about right here. These 2, that location, they're going to be in the first energy level. What kind of sublevel do they have? S. And I'm going to tabulate. Up above, I'm going to tabulate how many I have. I have 2 there in the S in the first level. It's a way of keeping track of electrons and where they're at. On Monday, we'll call this electron configuration. Okay? We'll just say, this is how the electrons are configured into their orbitals. All right? So we call electron configuration. All right. So we've taken care of 2 of the 13 and explained those 2. All right? Where's the next 2 go? They go in the second level, right? So you go 2. What kind of sublevel will they fill? The S. They always fill the S first in the sublevel, or in a level. So we go S, and how many can fill the S sublevel? 2. All right? We can go up here and we go, oh, there's only 2 in the first sublevel. They can only hold that many. So that's what we say. 2. Now this upper number is just a counting mechanism that says this is how many are in that sublevel. That's all it's doing. And the first number says where they're located distance-wise and energy-wise on that. So if on the periodic table, if we would stop there, what element does that describe? Did you were just stretching, right?
I can answer.
What's that?
I can answer.
What is it?
It's an
Beryllium. Guys, that's beryllium. Does that make sense? That is beryllium. So if I ask you for where the electrons are located in beryllium and what sublevels they're in, that would be what we call the configuration for beryllium. So your periodic table is your map. You are at beryllium. Okay, so then we got to go, where's the next electrons go? Because we're up to 4, we need to get to 13. So where's these next electrons go? They're in the P's. Okay, so the next electrons are in the P's. What level of P's? Yeah, they're in the 2s. They're in the second level. Okay, so when we're looking at this, these would be like the 2s2, and then we'll take these here are your P's. So that would be 2p what?
6.
Now we're at 10. So where are these electrons all located? Well, there's 2 in the first level, and they have an S sublevel, shape, sphere shape. There's 2 electrons in the second level of S's, they have a sphere shape, and then there's 6 total electrons in the P, and that would be like this, all full. Looks like that. Okay? We've got 3 more to account for. So we got to go out to the 3rd level. Okay, so what do you think these 2 electrons are here?
3s.
Yep, they're the S's, because we feel the S is always first in every level. 3s2. What element am I at now? Magnesium. You can count too. You kind of know what that count would be. All right, we got 1 left. What is that 1 left? Where's it at? 3 P. And we're counting how many was in the P's, and there's only 1 in there right now. So that's the electron configuration, what we call electron configuration, where all the electrons are at in the atom. Now, eventually, we're not going to care about this 1s, or 2s, or 2p, but we're going to be more concerned about this outer portion here. So this outer portion we're going to be a lot more concerned about when we talk about reactivity, because these are the only electrons involved in bonding. These inner ones are called inner electrons. We don't care about them. But to get the outer electrons, we've got to configure the inner ones to see where we're at. Okay, so that is it. And then we'll build upon this, the electron configuration, on Monday and into Tuesday a little bit. Okay? All right, I've got a short little